Mars, the very name evokes a sense of wonder, a celestial neighbor draped in hues of rust and gold. It hangs in our night sky, a fiery beacon igniting our imaginations. What secrets does this mysterious world hold? Could life in some form cling to its dusty surface? The question tantalizes us, drawing us ever closer to Mars' embrace. Mars is a world of stark beauty. Towering volcanoes pierce its thin atmosphere. Vast canyons scar its surface, hinting at a turbulent past. And at its poles, icy caps gleam under the faint light of a distant sun. This is Mars, a planet of contrasts, a place of endless fascination. But Mars is more than just a beautiful sight. It is a challenge, a mystery waiting to be unraveled. It is a potential cradle of life, a mirror reflecting our own planet's past and perhaps its future. And as we stand on the cusp of a new era of exploration, Mars beckons us to unlock its secrets and reveal the truth about our place in the cosmos. For millennia, humanity has cast its gaze towards Mars, captivated by its fiery presence. The red planet, with its distinct hue, has always stood out in the night sky, a beacon of mystery and intrigue. Ancient civilizations wove tales of gods and monsters, projecting their hopes and fears onto the red planet's mysterious face. To them, Mars was not just a distant world, but a powerful symbol, a celestial entity that influenced their lives and destinies. The Babylonians called it Nergal, their god of war, while the Romans bestowed upon it the name of their own deity of battle. These ancient cultures saw Mars as a harbinger of conflict and strife, a celestial body that mirrored the tumultuous nature of human existence. But Mars was more than just a celestial omen. It was a world unto itself, a planet that held secrets waiting to be uncovered. As our understanding of the cosmos grew, so did our fascination with Mars. Its movements across the sky, intricately charted by early astronomers, hinted at a complex cosmic dance. These early observations were the first steps in a journey that would eventually lead us to the surface of Mars itself. These observations laid the foundation for our understanding of the solar system, a celestial ballet with Mars playing a starring role. The red planet's orbit, its retrograde motion, and its proximity to Earth made it a focal point for astronomical study. As telescopes improved, our view of Mars sharpened. The once blurry and indistinct disk transformed into a world with surface features, polar ice caps, and seasonal changes. Giovanni Schiaparelli's observations in the 19th century revealed what he described as canali, channels on the Martian surface. These so-called channels sparked a wave of speculation and excitement. These features, later found to be an optical illusion, sparked imaginations worldwide. The idea of canals on Mars suggested the possibility of intelligent life, a civilization capable of engineering feats on a planetary scale. Could these be evidence of an advanced Martian civilization, tirelessly carving canals to irrigate their arid world? The notion was tantalizing, and it captured the public's imagination like never before. The idea took root, fueled by Percival Lowell's fervent belief in a dying Martian civilization desperately clinging to survival. Lowell's passionate advocacy for the existence of Martian life brought the red planet into the spotlight. Lowell's detailed maps of the Martian canals, though ultimately proven inaccurate, ignited the public's imagination, propelling Mars into the realm of science fiction. His work inspired countless stories and theories about the red planet. H.G. Wells' The War of the Worlds, with its terrifying depiction of Martian invaders, capitalized on this fascination, cementing Mars as a planet of both wonder and fear. The red planet, once a distant point of light, had become a central character in our collective imagination, a symbol of the unknown and the possibility of life beyond Earth. The dawn of the space age marked a turning point in our relationship with Mars. It was a time of boundless curiosity and unbridled ambition, as humanity set its sights on the stars and beyond. The red planet, once a mere speck in the night sky, began to capture the imagination of scientists and dreamers alike. No longer a distant point of light, Mars transformed into a tangible destination. Telescopes revealed its mysterious surface, sparking questions about its composition, atmosphere, and potential for life. The allure of Mars grew stronger with each passing year. In 1965, Mariner 4, a NASA spacecraft, completed the first successful flyby, beaming back grainy images of a cratered, seemingly lifeless world. These images, though rudimentary, were a monumental achievement, providing humanity with its first close-up glimpse of another planet. The dream of Martian canals and advanced civilizations faded, replaced by the sobering reality of a cold, arid planet. The romanticized visions of bustling Martian cities gave way to the stark truth of a barren landscape, challenging our understanding of planetary evolution. But even as these early missions dashed some hopes, they kindled new ones. The data collected hinted at a complex geological history, suggesting that Mars might have once harbored conditions suitable for life. This revelation fueled a renewed determination to explore further. Subsequent probes, like the Viking orbiters and landers, revealed tantalizing hints of a more dynamic past. They conducted experiments, analyzed soil samples, and sent back detailed images, painting a picture of a planet that had undergone significant changes over billions of years. Images from orbit showed evidence of ancient riverbeds, vast canyons carved by catastrophic floods, and sedimentary layers hinting at a watery past. These features suggested that Mars was once a much warmer and wetter world, capable of supporting liquid water on its surface. The Viking landers, tasked with searching for signs of life, yielded ambiguous results, further deepening the Martian mystery. Their experiments, though inconclusive, opened up new avenues of inquiry and set the stage for future missions. The question of life, past or present, remained unanswered. Yet the tantalizing possibility that Mars might have once supported microbial life kept scientists and researchers intrigued, driving them to develop more advanced technologies and methodologies. But the quest for knowledge continued unabated. Each mission built upon the discoveries of its predecessors, gradually unraveling the secrets of the Red Planet. The pursuit of understanding Mars became a testament to human ingenuity and perseverance. New generations of rovers like Spirit, Opportunity, and Curiosity touched down on Martian soil, their instruments probing the planet's secrets with ever-increasing sophistication. These rovers were equipped with cutting-edge technology, allowing them to conduct experiments and gather data with unprecedented precision. These robotic explorers traversed vast distances, drilling into rocks, scooping up soil samples and analyzing the Martian environment with unprecedented detail. Their findings have provided invaluable insights into the planet's geology, climate, and potential for habitability, bringing us closer to answering the age-old question, is there life on Mars? One of the most profound discoveries in recent years has been the confirmation of liquid water on Mars. This revelation has sparked a renewed interest in the Red Planet as scientists and researchers around the world ponder the implications of this finding. The presence of water is a key ingredient for life as we know it, and its discovery on Mars opens up a myriad of possibilities for future exploration and study. While the planet's thin atmosphere and frigid temperatures make the presence of liquid water on the surface a fleeting phenomenon, evidence suggests a different story beneath the surface. The harsh conditions on the Martian surface, with its extreme cold and low atmospheric pressure, mean that any liquid water would quickly evaporate or freeze. However, beneath the surface, where temperatures are more stable and pressures higher, water can exist in liquid form, protected from the harsh environment above. Radar data from orbiting spacecraft revealed signs of subsurface lakes, vast reservoirs of liquid water trapped beneath the Martian polar ice caps. These findings were made possible by advanced radar technology, which can penetrate the surface and provide detailed images of what lies beneath. The discovery of these subsurface lakes has been a game-changer in our understanding of Mars, suggesting that the planet may be more hospitable to life than previously thought. These hidden oases, potentially harboring remnants of ancient life, have become prime targets in the search for Martian organisms. Scientists are particularly interested in these subsurface lakes because they offer a stable environment where life could potentially exist. The water in these lakes could provide the necessary conditions for microbial life to survive, protected from the harsh surface conditions. But the evidence for water's past presence on Mars extends far beyond these hidden lakes. Geological formations on the Martian surface, such as ancient riverbeds and dry channels, suggest that water once flowed freely across the planet. These features provide a glimpse into Mars' wetter past, when the planet may have had a more Earth-like climate, Curiosity's exploration of Gale Crater, a site once thought to be an ancient lakebed, uncovered compelling evidence of a watery past. Sedimentary rock formations, mineral veins, and other geological features all point towards a time when water was abundant on Mars. These discoveries have provided valuable insights into the planet's history and its potential to support life, and rounded pebbles all pointed towards a time when water flowed freely across the Martian surface. These rounded pebbles, shaped by the action of flowing water, are clear evidence that Mars once had rivers and streams. The presence of these features suggests that the planet had a more temperate climate in the past, with conditions that could have supported life. These findings have profound implications for the possibility of life on Mars. The presence of water, both past and present, increases the likelihood that the planet could have supported life at some point in its history. Researchers are now focused on finding more evidence of past life and understanding the potential for current life in the subsurface lakes. On Earth, where there's water, there's life. This fundamental principle drives the search for life on Mars. By studying the conditions that support life on Earth, scientists can better understand the potential for life on Mars. The discovery of water on Mars has provided a new avenue for exploration and the possibility of finding life beyond our planet. While the Martian surface may be a harsh, unforgiving environment, the presence of liquid water beneath the surface raises the tantalizing possibility of subterranean life, eking out an existence in the Martian depths. These underground ecosystems, if they exist, could provide valuable insights into the potential for life on other planets. The search for life on Mars continues, driven by the hope that we are not alone in the universe. Adding to the intrigue surrounding Mars is the detection of methane in its atmosphere. Methane, a simple organic molecule, is often considered a potential biosignature, a chemical indicator of life. On Earth, the vast majority of atmospheric methane is produced by living organisms. While the source of Martian methane remains a mystery, its presence has fueled speculation about the possibility of microbial life lurking beneath the surface. Could these methane emissions be telltale signs of Martian microbes, exhaling this gas as a byproduct of their metabolism? The discovery of methane plumes, localized bursts of this gas emanating from specific regions on the surface, has further intensified the debate. These plumes, often seasonal in nature, suggest a dynamic process, potentially linked to geological activity or biological processes. While the methane mystery is far from solved, its presence serves as a potent reminder that Mars is an active world, a planet with secrets yet to be revealed. As we continue to explore the Red Planet, the search for the source of this mysterious gas will undoubtedly remain a top priority.